What's up, Algebra 2 Honors? This is Mr. White coming at you with the video for our Unit 2B test review. All right, so let's go ahead, hop right on into it. Our first one here. Where to put this? We want to know the vertex of this function. We are in factored form, recognizing this as factored form, and a couple of different ways we could approach this, but I like to show, let's go ahead and draw this. We see our two factors, so we know our x-intercepts are going to be these same numbers with the opposite sign. So I'm going to have an x-intercept at 2, -2 that is, -2 and +6. I want to know my vertex. I know my vertex, the axis of symmetry goes through my vertex, so I need to see what is halfway between these 2 points. Well, from -2 to 6, that's a difference of 8. So I need to be halfway. So what's half of 8? 4. We can show it this way. 6 minus -2 divided by 2. Just take the average here. So I know now that is not the axis of symmetry here. That's just the midway between these two. So we have a difference of 8. So we need to be 4 units away from each one of these points. So 4 units away from -2 is +2. 4 units away from 6 is 2. So now I know my axis of symmetry is x equals 2. That is the x coordinate of my vertex. So now I'm looking at 2 plus 2 times 2 minus 6, that is 4 times -4, that equals -16. That is the y coordinate of my vertex. So my vertex is 2, -16. All right, so if we want to know what word describes our roots here, we're talking about using our discriminant. We could check to see if this can be factored, but let's go straight to our discriminant. B squared minus 4 times A times C. We've got 3 squared minus 4. A is 1. C is 4. That gives us 9 minus 16 equals -7. A negative discriminant means we know we're going to have 2 distinct imaginary roots. All right, now we're going to need to see which one will have 2 rational roots. Similar type problem. All right, we're looking at our discriminant of each one. So let's just go ahead. Our first one, we've got b squared. So 1 squared minus 4 times 1 times 2. Hopefully you can look at that and see, well, that's going to be a negative number because that's going to be 1 minus 8. So that's going to have 2 imaginary roots. 2 distinct imaginary roots. All right, let's look at this one. We have 1 squared minus 4 times 1 times -2. So now we've got 1 plus 8 equaling 9. That's a positive number, but what does that mean? Does that mean I'm going to have rational roots or 1 real root? Well, we got to remember, if we've got a perfect square discriminant, then we're going to have 2 rational roots, 2 real roots, 2 distinct real roots, but they're going to be rational. So this one is going to have 2 rational roots, 2 distinct. Okay, moving on. What is the solution set here? All right. So we need to recognize, how are we going to solve this? Oh, well, we can factor. All right, always look to see if we can factor. We can factor out a 2. So that gives us x squared minus 25 equaling 0. If we divide both sides by 2, that leaves us with x squared minus 25 equals 0. We need to recognize this as a difference of 2 squares. Well, let's just go ahead. That comes out to x plus 5, x minus 5. Always want to point out when we have a difference of 2 squares, one of our special factoring cases. But Normally, when we have the x squared with no other variable, we want to isolate that x squared. So I'm just going to go ahead and show it that way now. We add that 25 on both sides. Now, when we take the square root, we get x equals positive and negative 5, which we would get if we solve this one through right here. So here's our solution set, negative 5 and positive 5. Now we have to find our solutions here. We see all of our answer choices are radicals, irrational numbers. So we know we're going to use our quadratic formula. So let's go ahead. We got negative, and I want to show it this way, just to be fully thorough. X is going to equal negative b plus or minus the square root of b squared minus 4 times a times c, and all of that divided by 2a. So x is going to equal, we've got 2 plus or minus the square root of 4 plus 68. All right, negative 4 times 1 is negative 4. Negative 4 times negative 17 is a positive 68. That is divided by 2. So we have 2 plus or minus the square root of 72 divided by 2. 72, that's a pretty big two-digit number there. Let's see if it has any perfect square factors. 72 divided by 2 is 36. Hey, 36 is a perfect square. So we can rewrite this as, I'll just show it over here, square root 36 times 2. So we've got 2 plus or minus, we can pull out the square root of 36, which is 6, times square root of 2 divided by 2. Already we see we can eliminate those two choices. Now let's look at our fraction here. 2 divided by 2 is 1, plus or minus 6 divided by 2 is 3. So we have our conjugate pair, 1 plus or minus 3 square root of 2. So we have 1 plus 3 square root of 2, 1 minus 3 square root 2. Another one where we've got to select all of our correct answers. We have all integer values. So we're not going to use our quadratic formula this time, but we do need to have it set equal to 0. So x squared plus 4x minus 12 equals 0. Two factors of negative 12 that add up to 4, x plus 6, and x minus 2 equaling 0. And our shortcut tells us these are the two numbers. We just need to switch the sign, but being thorough with it mathematically, x minus 2 equals 0. Subtract 6 on both sides. Add 2 on both sides. So we have negative 6 and positive 2. All right, now we have a fun one right here. Well, I think they're all fun. Some more fun than others. All right, first thing I'm going to do here is, well, start off treating our x's in here. So we need to treat this entire binomial as though it were just one variable. We need to isolate this binomial. So let's start off adding 12 on both sides. Now we need to multiply both sides by 2 so we can clear that fraction. Now we take the square root of both sides. Now let's go ahead and check. 30. Does 30 have any perfect square factors? Well, one thing we can do is just say, well, what are the factors of 30? We have 2 and 15, 3 and 10, 5 and 6. None of those are perfect squares. So that is not going to be simplified. Now let's go ahead. Now we need to isolate this x. All right, so normal, regular algebra 1 type problem at this point. Let's see here. Add that 5 on both sides. And then divide everything by 3. And we can write it this way. I don't like the way that looks. And it says write our solution using our curly brackets. So, and let's see, I'll do it this way. All right, so we see the answer one way right there. Let me just show it a different way right here. 5/3 plus or minus the square root 30 divided by 3. Notice I am leaving my answer like this. Yes, 3 does divide into 30, but we're talking about the square root of 30. So there's no further mathematical simplifying we can do right there. Okay, now the solution set for this. This is where we need to connect. Our solutions are the x-intercepts. So we're intercepting, we have -2, and we're at 2. And yes, -2, 0, 2, 0 in parentheses. Those are the intercepts, which are the same as the solutions, -2, 2. All right, now this one, what are the factors? All right, so again, we need to look at the intercepts. We're intercepting at -3 and +1. Those are the intercepts, those are the solutions. And we know the factors, we change the sign and we create a binomial. So we're talking x minus 1 and x plus 3. Ooh, this one barely fit in here. Actually, I can move this, can't I? I can't move it. What if I go full screen? Makes it a little better. Okay, anyway, let's go back. We want to know the equation. All 4 of these are in vertex form, so we just need to match to our vertex. Where is our vertex? We have our vertex at -3, -1. So we know our x coordinate is going to go in with the x with the opposite sign, so we can rule out our -3s. So we're looking at +3 and -1. But which one is it? Now we need to recognize that we are pointing down. Our parabola is opening down, so that means it's going to have a negative leading coefficient right there. So it is our y equals negative quantity x plus 3 squared minus 1. All right, what is the vertex of this function? Now I want to show this 2 different ways, and we'll see which way is easier. I think I know which way is going to be easier, but anyway. First thing we want to do is find what is our axis of symmetry. So our axis of symmetry, -b divided by 2a, is going to be a -12 divided by 2 times -3. I really have this thing for neatness now. There. Not saying I have the best handwriting, but I do like to be as neat as possible. So that gives us a -12 divided by a -6, which is a +2. Now we need to substitute that and say y equals -3, 2 squared plus 12 times 2 minus 10, which is going to be -3 times 4 plus 24 minus 10, which is -12 plus 14 equals 2. So our vertex here is 2, 2. All right, now the other way we could have done this is if we complete the square, we're looking at negative 3x squared plus 12x minus 10, set that equal to 0. Divide everything. Now I'm going to divide by a. So dividing by negative 3, that gives us x squared minus 4x plus 10 thirds equals 0. And now I'm going to show this a little bit different than the way we looked at solving quadratics with completing the square, but now I just want to get the vertex form of the function. X squared minus 4x, and then we've got plus 4 divided by 2 squared plus 10 thirds. Now, since we added 4 divided by 2 squared on this side, we need to subtract it over here. So minus 4 divided by 2 squared equals 0. So over here, this is going to give us x squared minus 4x, 4 divided by 2, 2 squared is 4, so plus 4, plus 10 thirds minus 4. All right, now we've got x minus 2 squared. Wait a minute. Plus 10 thirds minus 4. Remember when we divided everything by negative 3? Now we've got to multiply everything by negative 3. So this will give us negative 3 x minus 2 squared minus 10 plus 12. So that comes out, yeah, I know I dropped my equals 0. So really what that comes out to is, well, we're in f of x. So f of x equals negative 3 x minus 2 squared plus 2. Yeah, we see there a long kind of roundabout all around the mulberry bush. The monkey chased the weasel. And we still get our vertex of 2, 2. There, okay. All right, now we want the vertex form of this function. So what we need to do here, if you remember from the video, I said we have to do a middleman. We have to multiply this out. So we have x squared minus 2x plus 10x minus 20. Combine our like terms. We have x squared plus 8x minus 20. So we're going to have y equals x squared plus 8x plus 8 divided by 2 squared minus 20 minus 8 divided by 2 squared. We added 8 divided by 2 squared, so we have to subtract it on the same side to keep a balance. So that's going to be x squared plus 8x. 8 divided by 2 is 4. 4 squared is 16 minus 20 minus 16. So this is going to be x plus 4 squared minus 36. That was kind of quick, I know. All right, last one. What is our solution set here? What is our solution set? Let's see, we have 8, negative 2. That's not going to work. It cannot be factored. So we want to look at solving this negative b plus or minus the square root b squared. minus 4ac divided by 2a. So this gives us 2 plus or minus the square root of 4 minus 32. Negative 2 squared is 4. 4 times 8, 32. 4 minus 32 divided by 2. So we have 2 plus or minus the square root, 28, divided by 2. Hopefully you can quickly recognize that 28 has a perfect square factor of 4. So that is going to equal 2 plus or minus. Once again, we pull out the square root of 4, which is 2. 2 square root 7 divided by 2. We have a fraction that can be simplified. 2 divided by 2 is 1. 1 plus or minus the square root 7. So our solution set, it doesn't specify, but I'll go ahead and write it. Our conjugate pair is 1 minus square root 7, 1 plus square root 7. Now, let's make that curly bracket look better. Okay, I'll leave it at that. All right, and we're done with this video here.